And let me just take a look at this title here. The title of 6.5 is more on dividing radical expressions. Right, so we're going to talk about some more steps in regards of dividing radical expressions. A great section. There is some work to it. And really quickly, let me just tell you that I'm looking at your homework here, and it looks like I haven't added these quizzes to 6.5 and forward. So just so you know, I will be adding some quizzes to 6.5, 6.6, the rest of the sections here, just to test your knowledge on these sections, because I think really they're very important, and it's great to be able to do all the problems for practice. But I want to put some quiz problems there, so that way you get to assess yourself, right? So I really think these quizzes are important. So why is this section so important? Because what we're going to see here is that, keep in mind that when we're talking about dividing, right, dividing is shown normally as a fraction. So the key thing to understand in this section, right, the big star, the big note to understand is that a fraction cannot contain a radical in the denominator. Right. So 5 over the square root of 2 is an incorrect way of showing a radical expression. We have to do something, right? We must eliminate the radical in the denominator. So in order to eliminate the radical in the denominator, you multiply the fraction by 1. Notice that I put this 1 in quotation marks, right? Because it's not an actual 1 that we're multiplying it by. I think this section is a great section because it really makes you think about what you've learned thus far, right? We need to get rid of the radical. All right, we need to get rid of the radical. It says multiply by 1. Once again, it's not really 1, right? But anything, same number on top, same number on bottom is always 1. Right? Examples of 1. How about the square root of 5 over the square root of 5? What do y'all think? Is that one? Whatever is the same on the top and the same on the bottom, whatever is the same on the top and bottom, what happens to them?
Cancel out.
They cancel out, which means what are you left with here? One. There you go. Same thing on top, same thing on bottom, cancel. Right? How about 5 plus square root of 2, 5 plus square root of 2. Are they the same thing on the top and bottom? Identical binomials. So do you see why I put that one in quotation marks? Because it does, both of these examples don't look like ones, but they are ones because same thing on the top, same thing on the bottom, cancel out. All right. So let's take a look at some examples. Oh, and one last thing that I want to mention here, right? I don't think I mentioned. Let me take a look here. In order to eliminate the radical, the denominator, you multiply the fraction by 1. Oh, this is called multiplying by 1 in order to eliminate the radical is called rationalizing the denominator. So whenever you're asked to rationalize the denominator, it means multiply it by 1 in order to get rid of that radical. Let's go to that first example. I had 5 over square root of 2. Now I'm going to rewrite that problem. I want you to think about what we've done thus far. Okay. We need to multiply this fraction by a 1, right? Quote unquote 1. So think about the index of the radical. What is the index of the radical?
2.
2, which means we need 2 of the same things. How many radicands do we have? How many of these do we have? There's only 1, 2 there, which means what do we need? How many more of them do we need in order to pull that out and not have a radical in the bottom anymore?
1.
1 more. This is our 1. Right? We multiply it by that same thing. Because now on the top is 5 square root of 2. On the bottom is square root of 2 times 2. And what comes out?
The 2's.
The 2. Right? Leaving us with 5 square root of 2 over 2. And this is called rationalizing the denominator. As you can see, our answer does not have a radical in the bottom, right? And we multiplied it by our imaginary 1. Does that make sense, y'all? Any questions? Next example. 14 square root of 3 over 3 square root of 2. I'll rewrite my problem here. What do we want to multiply this by? Remember, we want to get rid of this. What do you think?
Multiply it by that, the square root of 2.
Very good. We don't worry about that 3 because the 3 is not a radical. Does that make sense? Right?
Yeah.
The three is not a radical. That's a whole number. We only want to get rid of the radical. Right? The 3 is a number. Right? So very good. Right? So multiplying it by that on the top leaves us with 14 square root of 3 times 2. On the bottom, we're left with 3 times square root of 2 times 2. What do we pull out here? We pull that out, right? On the top, we can't pull anything out, so now let's just multiply it. That's 6. On the bottom, I'm left with 3 times my 2. But do I see any reduction here? Only looking at the whole numbers, not the radicals. What can be reduced here?
The 14 over 2?
14 over 2, right? The 2's gone. That 14 turns into a what?
7.
There you go. Right? Leaving us with an answer of 7 square root of 6 over 3. Any questions with this example?
So would it be wrong if you just kept it 14 square root 6 over 6?
Correct, because it's a fraction. And one thing that must always be true about fractions must always be in lowest terms.
Okay.
Right, so very good question. Let's not forget, fractions always in lowest terms.
So it would be the same thing if you just multiply like 3 times 2 and then you just like divide both numbers by 2.
Exactly. That's another option, without a doubt. You can do 3 times 2 to get 6, and then do 14 divided by 6 and reduce it. Very good. Right. One way or another, you should always get 7 over 3. On how you're reducing it, it's really up to you. So very good comment there. Good. Any other comments, questions there? All right, so let's bump it up a level here. How about example C? I got the third root of 250 over 9. So real interesting one. Let's take a look at this. First of all, we have only one radical, but it's this radical has a fraction. And we learned the property last time, right? We can rewrite this as two radicals, one on the top, one on the bottom. Remember, what is it that we're trying to do? We're trying to get rid of what radical?
In the denominator?
The one at the bottom. So now what do we have to multiply in order to get rid of that? Well,
9?
If we multiply it by a 9, well, now we got 2 of them in there, but how many 9s do we really need?
We need 3, so you multiply it by 2 9s?
2, and that's one option. This is going to make everything really big. There's another one that might make it a little easier. Let's just break up the bottom. What is 9 broken up? What times 12 gives us 9?
3 times 3.
There we go. Look, we already have 2 of the same numbers. What are we missing?
1 more 3.
There you go. Isn't that a lot nicer than these 2 9s?
Mm-hmm.
Even though that's also correct, don't get me wrong. Doing it by 9 times 9 also is the same thing, but 9 times 9 gives me 81. And do I really want to multiply 250 by 81?
Hell no.
Right? So let's do the third root of 3. Third root of 3 makes it a little nicer now, right? Now on the top, we have the third root of 250 times 3. On the bottom, we have the third root of 333. But now we're going to have to break up this 250 because 250 is a big number, and there's a possibility that we can pull some things out from that from the top now. Bottom, it's evident. All right, 3's out there, right? Bottom is definitely clear. 3's out there. Well, let's take a look at this 250. Let's break that up. What times 12 gives us 250? One option would be, I'm going to go with 25 and 10. 25 is a 5 and a 5. 10 is a 5 and a 2. So now we take a look at the top. The top now is a 5, a 5, a 5, a 2, and a 3. So on the top, what else are we pulling out?
The 5.
Very good. The 5, right? So leaving us with 5 on the outside, the third root of, and the inside we're left with 6. That entire thing is over 3. Right? So this is a great example of where these problems start getting a bit more interesting. When it's square root, it's easy. Hey, whatever that number is, one more time. But when it's the third root, now you really want to think about it. And if you would have done it by 9 times 9, you would have got the same answer. You just would have had bigger numbers. You would have to simplify your fraction, but it would have worked out as well. Very good. Questions. Let's do one more with the third root. Anyone need another minute to copy this down? All right, new board, example D. How about the third root of 3 over 5x to the power of 5, y to the power of 2? All right, so let's take a look. It looks like a really nice problem. Top is just the third root of 3. Bottom is a third root of 5. And let's break up those x's and y's, okay, everybody? 1, 2, 3, 4, 5. 1, 2. Because that's going to give you your clue on what you have to multiply it by. First of all, they got to be third roots. But what are we going to multiply it by? Anyone have any ideas?
Maybe XY?
What about
Y?
number? Let's start with the number. Any number?
5.
Well, how many of the, we need how many of the same things?
3.
3 of them, right? Well, there we got 1 5. How many more 5s do we need?
Oh, 2 more.
There we go. So a 5 and a 5. That would now make 3 5s. Right. So let's take a look at our x's. Well, there we already got 3, so we don't got to worry about that. But here we got 2. How many more x's do we need?
1 more.
Very good. Is this making sense, y'all?
Mm-hmm.
There we got 2 y's, so how many more y's do we need?
1.
There you go. So this is what we would multiply it by, because now looks like we would have 3's of things in the bottom. Does that make sense, y'all? So this is where that tricky part gets. This is a problem that I love to put on a test. Problems that look like this that make you think, what do I got to do? Right? So now we can put it all together. On the top, we have a 3. We have 2 5s, 1 x, 1 y. Bottom, this third root. I'll put my 5s together. It looks like I got 3 of them. It looks like in total I got, how many x's in total do we have in the bottom?
6.
Very good, right? We have 1, 2, 3, 4, 5, 6 x's. Good job. 1, 2, 3, 4, 5, 6 x's. And how many y's in the bottom?
3.
Very good, right? We got 1, 2, 3 y's. So y's, we got 1, 2, 3 of them. And now we're just pulling in groups of 3 in the bottom, right? Pull out a 5, pull out an x, pull out an x, pull out a y. Remember, we just multiply those. Top doesn't look like we can pull anything out at all. So let's just multiply that. All right, doesn't look like we can pull out anything on the top. Top is going to leave us with the third root, 75xy. The bottom's leaving us with 5x squared to the power of y. Any questions, y'all, with this example? These examples on 6.5 with this cube root and you're asked to rationalize are the ones that I really like to put on the exam because it really covers this entire section nicely. So, all right, let's take a look at the next example. Example E. How about something like negative 42 square root of 7 over the square root of 10 minus the square root of 3? I'll rewrite this problem. This one's interesting. What are we going to multiply this by?
The square root of 10 minus square root of 3. Okay, you need another one?
So, and think about it. If we do that, now it looks like this times that. But the question, will these radicals cancel out? No. But you're on the right track. Think about what we discussed earlier and think about the examples that we saw on 6.4.
Can we multiply it by its conjugate?
Great job. Because I want to go back really quickly and show you this example C. If we take a look at this example C, we have this times that. When we multiplied conjugates, look at what our answer was. A whole number. No more radical. Take a look at our next example. right? Same thing. We have this times that multiplied by conjugate. Look at that. A nice whole number. So if we multiply by its conjugate, it should always be what kind of a number?
A whole number.
There you go. Very good. Right. And that's what you're going to see with some examples on this homework assignment as well. I want you to be thinking, all right, the bottom is a binomial, right? Let's multiply it by its conjugate. So great job. Square root of 10 plus the square root of 3, top square root of 10 plus the square root of 3. Right? Because now it looks like negative 42 square root of 7, open parentheses, square root of 10 plus the square root of 3. The bottom looks like square root of 10 minus square root of 3 times the square root of 10 plus the square root of 3. Problem should be very easy. You shouldn't have to do a lot of work on the bottom. It's the top that you'll have to do some work. Right? We multiply here. What does that give us there? Negative 42 square root of what? We multiply the numbers in the inside because they're both radicals.
70.
Good job. Right? We multiply over here. That gives us, let me fix the 70, then look very nice. Multiply over here gives us negative 42 square root of what there?
21.
Good job. How about the bottom? Once again, these are called what?
Conjugates.
Conjugates. So it should be very easy. The bottom is really just going to be what minus what?
10 minus 3 squared.
Yeah. And now, because of the fact that you know that, hey, just do 10 minus 3. That's fine. Giving us the bottom to be what there?
7.
7. I don't need to see all those little steps. Now, if you want to show them, that's great, because remember, on test, sometimes if you mess something up, I'll give you partial credit back, right? So if you want to show that, that this there minus, that, you can. But if you do it perfectly, I mean, you could just state, hey, conjugate's 10 minus 3. You show me that, that's sufficient enough. That lets me know you know the property. And if you know the term and you know the property, it makes me very happy because you're understanding the math well. Right? So either way that you want to go works fine. Are we done?
No.
No, why not?
Because we're not. Can't you divide negative 42 by 7 to get the 6?
Very good. Remember, y'all, this is a fraction, right? This is a fraction. And notice that we only look at the whole numbers, right? All of these are all divisible by 7, right? Fraction always in lowest terms, right? These are not all nice whole numbers, all divisible by 7, right? All of them cancel out, leaving us with what instead now? Negative
6
square root of 70 minus 6 square root of 21. Very good. So a nice example that I'd like you to use